this was the major challenge. So what I find that particles and droplets perhaps is a problem to scale up, but bubbles is quite easy to scale up actually, and the property of bubble has a lot of applications, particularly if we are not able to scale up the irrigation, there's a big problem actually. And if you want to aerate the entire, let's say 20 acre of lake and pond, it's a big challenge actually, because the energy demand is going to increase significantly, and the aeration cannot be done actually. And aeration is one of the nature's technology which basically treats the water automatically, because the microbes and bacteria are already present in the water actually, and there is no need to do extra things, there is no need to do additional things. The available microbes and bacteria in the water itself is basically a kind of a self-cleaning mechanism which can provide a solution. So that's what it is called a green technology, where we're just using re-engineering the technology, aeration technology, and doing better things to purify the water. So here I will just talk about how this technology that we were working in the beginning, and then how this has been gone to be fundamental to the commercialization. So in the beginning, people were not believing me this bubble exists or not. That's the biggest question. 2017, perhaps a lot of debate in academic community was there. People were asking question, okay, microbubble exists or not? So of course we know the existence of microbubble is just a few milliseconds. I mean, after some seconds is going to disappear in the water actually. So how you expect the nanobubble is going to exist at all? I mean, so this was the biggest question that people were asking in the beginning. We answered the question by several ways. They exist, and the number is also tremendous. The number per ml of the water, the bubbles exist in millions and billions. That was something was missing by people actually in the beginning, because if the microbubble doesn't exist, why nanobubble? This was the paradox in the beginning, and people were asking question, how will you prove? So this was the beginning of my journey in this technology, and we provided the proof in the beginning in beginning of 2018. Oh, this bubble exists, and they are really nanobubbles. They are not particles. People are asking question. I mean, why this could be a particle as well? This could be contamination as well, because at nanoscale we can't see. We can't make a judgment. We can't make a we can't see first of all. So we can't make any judgment about the bubbles actually. And after proving that they are bubbles actually, and then we started doing more research on that. After 4 years of doing research on this actually, we developed a technology which is basically scalable, and now we are able to deploy in a large scale volume, nearly 20 acres of the area of the pond. We are deploying this technology. So I will just talk about this journey that I've done during my this period actually. So what problem typically we are looking for? If you look at the large volume of the water bodies, I mean, of course there is water demand. I mean, next world war is going to be on the water itself. So the clean water is again the sustainable goals. So how to treat a huge amount of water by using the technology? So the major problem that we normally see is the conventional aeration. If you see people use aerators and other things, is huge high energy demand actually. You cannot cater the 20 acre area because if you create bubbles using conventional method, there is a buoyancy, bubble rises in the liquid and it bursts. I mean, we can't sustain that actually. So what nanobubble basically does actually, it suspends in the water and it uniformly go everywhere, all corner of the pond actually. It doesn't rise because of the buoyancy, because the size is too tiny, and because of the size, very small size, the transfer efficiency becomes very high actually. So nearly, if we look at the conventional aeration, the efficiency goes around 10% to 20% at max, if I say. But by this way of doing things, we are able to achieve 90% of the efficiency because of the size of the bubble reduced from the micron to nano size actually. So efficiency is one of the key which is playing a major role here, and several contaminants present, like surfactant molecules present in the water, fog, and several other contaminants is already present in the typical lake water actually, and also there is a weak nitrification and various problems actually, a lot of problems. Even if you want to clean it by the conventional way of doing things like coagulants or flocculants, You need to put tons of chemicals in the water, and that is really not feasible. So how to do the things by doing green technology just by nature's air bubble? How this can be treated? That's what the objective was of our problem, and we have solved this problem. We have designed the machine to create nano-sized bubbles. So you can see from here actually what is called nano-sized bubbles. So typically the size is less than 200 nanometers. This is the typical size of nanobubbles, and of course I said nano-size things cannot be seen actually, but somehow I have captured the image. Somehow I have recorded the videos and how it looked like. If you see it from here, this is what the nano-size bubbles look like. They are under random motion, and they do not rise in the liquid because of buoyancy. And this is the typical physical solution that what I find during this time actually. What is the properties? Typical properties are again, as I said in the beginning, it doesn't rise in the liquid. It is suspended in the water, and it has a lot of other physics. I would say people ask question why they are stable. The biggest question people are asking. Okay, you are a scientist. How will you say a bubble is stable? So there must be reason for that. There is a scientific reason for that, and that paradox has been recently solved. Bubbles got a charge when we go towards nanoscale. Bubble got a charge, and the charge basically is significant, and this basically provides a force which starts bubble to coalesce further, and that's the reason that bubbles are going to be stable. And since they are nanoscale, the area is pretty high actually, and all the activities which occurs at nanoscale is very powerful. These bubbles, again, I said transfer resistance is very high because they are at nanoscale. The interface area is very high. One of the important properties basically bubble collapse. In the bubble collapse, actually, sorry, I have 22 minutes. So when bubble collapse, it forms radicals. That is the beauty. The radical forms, and radical is basically important for killing the bacteria, killing the chemical molecules. The long chain molecules like surfactant can be broken down in smaller molecules. So this is the typical property of nanobubble, which basically can cater almost all problem of the water that is in the lake or pond kind of water actually. There are several properties. I will try to skip those things actually. A lot of other benefits like almost all area of water treatment can be applied. Flotation, membrane cleaning, absorption, aviation, as I said, anaerobic digestion, and advanced oxidation, of course, is one of the area where this technology has a lot of potential actually because of its scalability. It can be scaled up in a bigger volume. We tried a lot of pilot trials in India. This is the typical image of the trial that we have done in Udaipur actually. You see, this is the typical algae formation and a pond water. Nearly the volume was 20-acre pond. We deployed this technology, and after you see the level of DO level was almost zero in the beginning. After treatment of 3 months time, entire DO level was under control. The DO level was seen to be 8.7 milligram per liter. So this was the typical results just after 3 months time we have seen actually. And similarly, there are more trials we have done, and now we are in a phase of commercialization of this technology. So develop a lot of machines, bigger machines. If you look at the power consumption of these machines are pretty low actually. For 20-acre pond, the power consumption is just 10 HP of the machine is required actually, which cannot be achieved by any of the method available currently. And there are several machines that are designed particularly for the lake and pond treatment actually. And this was typically from fundamental research to the commercialization that we have done in the past 7 years almost we've taken to take this technology from the lab to the commercialization. Thank you very much. This is my startup. It's called Nanofilter Technologies. So we built the machine, and we're selling the machines. Now the company is in break-even point. This year we are in profit.